This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to episode number 4. This is a continuation of episode 3, which was on RxJava. Part 1 ran a little long, so we broke it into 2 episodes. If you missed part 1, please go back and listen to episode number 3 so you can follow along. In this episode, we continue the RxJava conversation with Dan Lew and discuss many more intricacies of RxJava. We hope you enjoy it. Let's get back to it.
2 other operators that are very commonly used are the map and the flat map operator, right? When I started out, essentially, I tossed a coin and tried to use map, and then I was like, that doesn't work. Okay, so then let me try flat map. I'm like, that works. Okay. So it really took some time for me to sort of understand these, to sort of solidify the exact reason where I would want to use map versus where I would want to use flat map. The way I've sort of come up with an understanding is map is essentially like the alchemist's operator. So whenever you want to transform one object to another object, a single object to another object, you would do this with map. So you have maybe a JSON object coming in, like an observable of a JSON object, and you want to transform that to maybe a gold, exactly, yeah.
That's what alchemy is all about, right?
Yeah, there we go. You would typically use the map operator in that situation. Now, the flat map is similar, but there's one very key difference. The way I think about it is assuming you had a block of cheese, right? You have a block of cheese, and what you want from this block of cheese is a bunch of sandwiches. It might sound bizarre, but the beauty with this sort of thinking is it's so weird that you'll never forget it. So you take a block of cheese and you shove it through this operator called flat map. What this flat map operator does is it sort of shreds this into slices of cheese. So you have different slices of cheese. Now, slices of cheese basically means that there are many objects. So if you're returning a bunch of objects, how would you typically do this? Well, you would use an observable, right? Because essentially what an observable does is it emits a bunch of sort of events. And that's exactly what flat map does. It takes a single input, so in this case, a block of cheese, and it sort of makes slices of cheese. But here's where flat map becomes even more awesome. Assuming you don't want just to give slices of cheese to everyone, but you want to transform each slice of cheese to maybe a sandwich, then flat map gives you an operator where you can actually transform that. Now, if you wanted to only change, say, a block, a single slice of cheese to a sandwich, then a map would suffice. But if you had a single block of cheese that you want a bunch of sandwiches to come out from, then you would use flat map. Does that make sense, or am I just crazy?
That makes some sense. I mean, I think of map and flat map a little more in terms of what level of order they're at. And map is just plain object to plain object.
Mm-hmm.
Yep.
Whereas flat map is you put in a plain object, but what you get out is a different observable stream. And so in this case, your example, you're putting in is cheese, and what you're getting out is an observable of slices.
Exactly.
But it could be anything. It could be an ID, and you flat map that to an observable that returns the data behind that ID. So that's something I use constantly.
Invariably, if you're using RxJava, I would be very surprised if you didn't run into the map or the flat map operator. I mean, you're going to run into it eventually.
You're going to run into it, but you're going to not understand the difference for a while.
Yeah. It's going to be 2 of the main observables that you use all the time. So, Speaking of multiple observables, at times you're going to have 2 observables and you need to combine them into a single observable. And there's the zip operator for that, and it allows you to combine multiple observables into one single observable. An example of this might be making parallel network calls, and then when you get the results back, you can combine them into a single observable, which you can work with at that point.
Yep. The zip operator is pretty useful that way. There are other operators, and I guess we're going to touch on those. For example, I guess another one that's very similar is CombineLatest. Dan, do you want to sort of walk us through what CombineLatest does?
Yeah, I mean, I love this one because it basically, you take multiple observables, so they're all emitting whatever items they want, multiple times possibly, and it executes each time that one of the observables emits a new item. So it basically lets you monitor the state of multiple observables at once in one compact area. And so I love this, for example, validating input. So suppose I have 3 formed fields, and I want to activate the submit button when all three form fields are filled with valid data. Like that's possible with a bunch of booleans and method calls, or I can just have an observable that represents each form's output and whether it's valid or not. And then I can combine all of that, and once I get valid output from each of the observables, then it enables the button.
That is a great example.
Here's one question though. We talked about zip and we talked about combineLatest. For a long time, I really didn't quite understand the difference between, like, specifically what's different between zip, combineLatest, and I also came across this operator called switchMap. Now, if you look at all of them, essentially the intention seems to be very similar. Like all of them seem almost similar, right? But here, so what I did in order to sort of understand the difference is there's this concept of marble diagrams that's used heavily throughout Rx. And what it does is it sort of gives you a visual representation of like what's really happening. And many a time, if you just have a look at these marble diagrams, it just clicks. It becomes immediately clear. So when I looked at zip, the marble diagrams for zip, combineLatest, and also switchMap, it immediately became evident. For example, with zip, what happens is if you have two observables emitting events, what zip does is it forcefully combines each of the items from both streams in a sort of synchronous manner. Well, actually, synchronous is not the right word. It waits to make sure that each item emitted from both streams is collected and spit out into one sort of result.
Yeah, now, I mean, it's like a physical zipper where the left side zips and the right side and the left and it's the left and right, always the next one of each.
Oh, so that's where they use like the term zip.
I'm guessing that's where I got it from.
See, learning every day. There's something to learn every day. combineLatest is a little different in that like one of the streams start emitting objects. What it basically does is it takes the latest object from the other stream, combines them, and gives it to you. So that's how it's a little different from zip. Again, just look at these marble diagrams and it makes it so much more easier. This is like, at least for me, it's a little hard to explain, but if you look at the marble diagrams, it's like boom, like in 1 second, you just immediately understand what's happening.
So,
sure.
Kaushik, real quick, can you explain what a marble diagram is for those not familiar with a marble diagram?
Sure. So again, I guess it's the folks over at Microsoft, or maybe it's someone else who came up with with Rx in general. They realized that many times these streams, if you want to understand these things easily, a visual representation of this thing is super easy, right? So what they typically do is like they have like an observable which they represent with a line, and essentially they have events being represented by these marbles, right? And they have like the operator in between, and then in the end they show the result. Visually they show the result of how this would actually look like. So if you had like a stream of objects flow through, they would show like what the combined result would be based on the operator that you're passing. So we'll again put a link to the show notes to like these marble diagrams, and specifically if you see like between zip, combineLatest, and switchMap, it really kicks in. So if you go to the RxJava wiki, like they have these marble diagrams all over. So
Dan,
cool.
I know that you had talked before we'd hopped on the show a little bit about the observable called DistinctUntilChanged. I haven't worked with this. Would you mind talking about it a little bit?
Yeah, I love this one. So basically, any given observable will be emitting a bunch of items, and sometimes you don't really care if it emits the same item over and over again. So this happens a lot in one part of the Trello application in particular. When you're loading all the card data, there's like 5 different databases that we're loading information from, and it kind of has this tree-like structure where if you change the card, then it trickles down and changes all the attachments and comments and all that stuff. So this can result in a lot of repeat calls because maybe some of the same data is repeated between different emissions. DistinctUntilChanged essentially says, don't emit if the value hasn't changed since last time.
Gotcha.
So, for example, you might have like a observable that represents whether your app is connected to the internet, and you might just get a bunch of events that say, "Yep, still connected. I'm still connected. I'm still connected." And if you only care about whether it switches from yes to no, then you can use DistinctUntilChanged to just filter out all of the junk.
That's awesome. I didn't even know that was. There's so many observables inside of RxJava that when you look inside the wiki and then on the website, There's just so many of them to learn about, and this is another great one that just kind of appeared out of the blue just now for me. That's great.
Yeah, I mean, there's still a bunch that I'm sure I could learn about and love. There's a lot in there.
Yeah, I was going to say, under the hood, from what I've read online a lot, is under the hood, under a lot of the observables, Observable.lift is used. Do you know a little bit about how lift works and so forth, or anything about that?
Yeah, I mean, so most of the operators that you want are built in. But of course, like, what happens if you want to write your own operator? What happens if you want to write your own transformation? So, for example, one thing that we wanted to do a lot in the Trello app is we don't like null because it just like blows up your app. We'd rather have some sort of default value, like instead of a null list, just an empty list. And so we could write that as a map, but it'd be really easier if we just write our own operator that we can apply everywhere. And so that's what lift is for, is essentially you can write your own operator and then use lift in order to combine it into the chain.
That's cool.
That makes sense. So a question that I usually always had with lift is basically, okay, so how is it really different from create, right? So, I mean, because I've looked at the lift documentation and it looks very sort of similar to like how you would use observable.create. So that kind of makes sense. I guess observable creates the observable, but like with lift, it's specifically like a reusable operator. Is that
because
sort of right?
Create basically creates something out of nothing. It creates a stream out of nothing, whereas lift takes a subscriber and based on what the subscriber is emitting, then transforms it and emits it to someone else.
Okay. Yeah, that makes a lot of sense. So while we're on this subject of like combining operators, the most recent blog post that Dan made was on the compose operator, and I had no clue about compose until I actually saw your blog post. So would you like to run us through that? I think it's an amazing and very useful operation.
Yeah, I had no idea it existed until about a month ago, which makes me sad because I love it now. So a lot of the times you want to keep applying the same series of operators to something. Like a really common pattern is applying schedulers. I want the work to be done off the main thread, and I want the reaction to be on the main thread. And so we'd written these methods that just wrap an observable and call those. What compose does is it essentially lets you inline repeatable transformations. And if you don't use compose, you can still do this with observables, but you end up having to use methods and wrap things around, and the resulting code is really ugly. But if you use compose, it's essentially the same as, take these 3 or 4 operators and just stick them in here in a reusable manner.
Yep, that makes sense.
Very, very interesting. And I think your blog post covers it very well when you use the example of subscribing and reacting. So if for the listeners that are listening, definitely check out Dan's blog post. We'll link it in the show notes. It's very, very interesting to see how you can use the compose operator to help your code. Another observable that I'm a huge fan of is the filter observable. And what it allows you to do is basically adjust a stream of data to just return what you need. And a good example of this is, let's say you have maybe an order filter mechanism in your app, and it shows the customer's orders, and you only want to show the orders that are between a certain price threshold, maybe between $100 and $250 for whatever reason. You can use the filter observable to actually filter out those orders, so you can only work with the exact orders that you'd want to. So it allows you to easily filter out different objects at runtime. Does that sound about right, guys?
Yeah.
So a question that I had with filter is, so filter basically allows you to sort of chop up, like assuming you have like a bunch of objects coming in from your observable stream and you wanted only some of them to flow. What happens if you have only 2 objects being emitted from the observable and basically your filter cuts them both off? So there's this concept of completion that I think is like important to sort of like bring out, and I'd like to like sort of like bring it out here. So assuming I filtered both events, what happened? Does it just pause? Does it stop? Does it not do anything? Does it continue? Like, how does that work here?
Yeah, so I mean, all observable streams have a kind of a life cycle to them, which is that on next is called multiple times, and on next is kind of like each item being admitted, and then they terminate in one of 2 ways. If they terminate at all, they may never terminate, but if they do, it's in one of 2 ways. One is on error, which means that something happened that's critically bad and destroyed whatever could be done with this observable, and that's where you can kind of handle the error. And the other is on complete, which means this observable has indicated that it's done emitting things. It'll never emit anything ever again. And so you know that after either of those two terminal states, you'll never see another item. So that's essentially what happened. Is if you want to know if the difference between handling those items and knowing when the items stop flowing is important, then you should be hooking into like on complete instead of on next.
This is such an important thing to understand, especially initially. For me, it took me some time to get that aha moment. I didn't really sort of grasp when the completion sort of aspect happens. But once you understand this, then it just like a lot of when you're debugging or operators don't seem to be doing what you suspect that they should be doing, just having a grip on this concept sort of like immediately helps with those kind of situations.
Yeah, I've got a couple other favorites I want to just mention. There's an operator called take, which allows you to just grab the first n operations from any given stream. And so very often, I just want to see the first item emitted from any given stream. And so for that case, I'll just do take one, and I get the first item, which is great. Also used all the time, like we've been talking about schedulers. What are the actual operators that run those schedulers? Are subscribe on and observe on. Now, if anyone has a mnemonic for remembering which is which, I'd love it, because I keep getting them. I cannot keep them straight in my head. I always have to look it up. But basically, one of them tells you which scheduler to use for all of the actions that happen during the subscription, and one of them tells you what to do in the reaction phase, which thread to run on for that.
The way that I usually remember that, Dan, is I think of subscribe on as like I'm going to subscribe to a magazine subscription, so I pay some money, and then some work is done in the background at some factory where they make some magazine, and I don't care how it's done, but I want to observe the magazine in some form. So I subscribe to a magazine, and then I observe the magazine, and observing it means I actually have it in my hand, so it's been delivered to me at that point.
That is a great way to remember it.
So I mentioned earlier about hopping between threads. Say you wanted to hop to the main thread and then again switch back to a background thread, then switch to a computation thread, switch to an IO thread. The way you would do it like intermittently is using the observe on operator. You can't use the subscribe on scheduler there. So assuming you're making the network call, then you want to hop back, do something on the main thread. In order to do that, you would actually have to use the observe on operator. The way I think about it is subscribe on is like the sort of conclusion, right? Like, so in the end, when you say subscribe on, it's like the final subscription that happens. Again, yeah, people sort of think of it differently, but a key point that I learned along the way is if you want to like quickly switch between threads, the way you would do it is using the observe on operator. If you like add a bunch of subscribe on operators, I don't think they have any effect. It only talks about the final subscription. There are a bunch of other operators as well, but again, this is something that we just have to explore. For example, there's debounce and buffer, which I've personally used a lot. I have a couple of blog posts also talking about those, and we'll add a link to all of those in the show notes. But I mean, if we went ahead and discussed every single operator on RxJava, it would probably take us another 2 days to complete this episode.
And the hard part too is that usually these things don't stick until you have a specific use case for them.
Yeah,
exactly.
Like you could write a blog post that's like, here's every single operator and why they're neat. And people would read it and just like nothing would get absorbed. So in some ways you kind of have to stumble in a little before you understand how great some of these operators are.
Exactly. And I think one of the things that usually stumble into eventually pretty early on, at least for me, was stumbling into subjects, and those are RxJava subjects. Now, have either of you guys used subject that much? I know that I use them in our app quite a bit.
Oh, absolutely. Yeah.
We use them a fair amount too. There is a lot of like debate over whether they should be used or not. There's this one great article that I've read that basically handles like when it's actually appropriate to use subjects. I think in RxJava in particular, you tend to use it more often because you can't actually monitor variables normally. Like in some other languages, you can actually have a variable that like when you change that variable, it automatically emits something that you can grab on for the observable. But in Java, you can't really do that. You always have to write some sort of Chrome around it in order to make that happen. So that's why I feel like a lot of subjects become useful.
if you want to sort of like allow events to pass through, like I'm guessing the only way you can do that is with subjects, right? For example, a common use case that I've found myself using is assuming you have like an edit text and you want to monitor like text changes, because I mean, maybe you want to do a validation or you want to like sort of do an auto search kind of a feature. It's very hard to sort of like not use a subject there. Like, I mean, it would be pretty difficult. Typically what I would use is like I would use a subject, and as the events come in, I would like call on next on that subject. And then basically how it would react is I would sort of like create a subscription to that subject and use it that way. So subjects, again, there are different kinds of subjects. There's like an async subject, there's a behavior subject, there's a publish subject. What's the other one that I'm missing? Replay subject, exactly. Thanks, Donn.
There's actually, in the Rx Android library, there are ways to hook into like edit texts for changes.
How do you do that?
Someone's written.
Yes.
I think it's in View Observables, and they add their own text watcher that basically acts as an observable, as a created observable for that edit text.
Time to go rewrite all the view code.
Yeah, I find that subject most often happens when I have a variable that I need to emit new versions of. And like you said, if you can use that for things like edit text validation, but anytime I've just got a variable where I want to inform other people when it changes. That tends to be when I have a subject.
Kaushik, you used the subject in your simple event bus blog post, didn't you?
So this is again like a huge topic. Like people think event buses, like RxJava replaces event buses, and again, we're not going to go into that because again, that'll require another whole show. But tried to do essentially is I used RxJava in order to create an event bus. So it wasn't that RxJava replaced the event bus. I just used I used specifically a publish subject and a sort of singleton kind of object that would listen and publish these events outside. We'll add a link to the show notes. I've gone into great detail as to how I did it. The main reason I even wrote that blog post was because it was so simple to actually use RxJava and create the event bus. And that was basically what I wanted to draw out. It's so easy to like work with these kind of situations, especially anytime you think about any situation that has to deal with events, like events flying around, then you almost invariably know that RxJava has a mechanism of doing it. So I wrote that as a sort of proof of concept to myself to implement an event bus using RxJava. Now, I know that the Rx Android project, at least the specific branch of it, also had like an event bus implementation, and that was probably more flushed out, but it never saw the light of day, did it, Dan? Do you have any idea about that, or is it actually there and I've fallen off the wagon there?
I don't know the answer to that.
The last I saw, basically, there was like an implementation on one branch on GitHub, so we'll confirm that later.
Yeah, you can look into that. I mean, it's a little weird to combine. I mean, event buses and RxJava are kind of two different things. Like they can solve similar problems, but it seems kind of odd for me to say let's mash up the two, right. Because like what does that even mean? You're having two different flows of execution. One much more direct and one much more like event buses are all about broadcast information, and RxJava is a lot more about kind of directly connecting information to each other.
One thing that I wanted to talk a little bit about was handling errors with inside of RxJava and how that can help your application, how it makes error handling a lot easier, and that's done with the onError method inside of the subscription. I think we've all found that the crashes go dramatically down, and not to say that they definitely go away, because they definitely don't, but it makes it a little more graceful to handle. The one thing that I'd like to note, though, is that if you need to implement onError, because if you don't, you will not receive a crash. Your app will just magically just stop working. You'll click a button and nothing will happen, or you'll refresh the screen and nothing will happen. And I've run into this many times during development. I'll get something to work, and I will forget to implement onError for some reason, and then all of a sudden I'll introduce a bug a little bit later, and then the app just stops working. There's nothing in the logs, there's nothing anywhere, and I realize I forgot to implement onError. Have you guys found the same thing in your guys' development?
Oh yeah, plenty of times. There's a debugger you can attach to RxJava, And almost every time I do that, what I do is I end up finding some place where I didn't implement on error.
So what is this a different debugger than just a typical Android Studio debugger?
Yeah, well, there is some RxJava plugins that you can use, and one of them is a way to basically hook into every single notification that RxJava does. So every single time is onNext is called, every time onComplete, and every time onError is called. And so we've written a tiny little thing which basically spits out all of those notifications to Logcat, and it's a real fire hose of information, but occasionally it's useful for debugging real nasty RxJava problems.
Oh wow, that sounds super useful.
Is that open source, or is that something you guys have written and released, or what is that?
I mean, it's totally available. Yeah, the RxJava plugin and RxJava debug is part of the It's one of the RxJava extensions. As for the spitting out to Logcat, I mean, that's not open source, but it was like 5 lines of code, so it's not really. I mean, we could open source it if you really want, but it's not that hard to write.
Yeah, even a little blog post or a gist or something like that, I think would be very useful to a lot of people that are getting into RxJava, because they can actually see it inside of Logcat. That would be great. Just a recommendation.
We'll look into it.
So one thing that's I've always had trouble with, specifically with RxJava, and I still do. I mean, it isn't as easy, is testing with RxJava. So as most listeners know, testing is a dear topic to the show. Testing in RxJava is not as easy as you would typically like it to be. One approach I usually use is specifically if you're trying to get a bunch of objects from the database and it returns an observable of objects, then making it a blocking operator makes it very easy to test. But this isn't specifically something that you can always apply, right? So there are test schedulers that you can use, and if you use dependency injection, basically this is easy. Anytime you have an RxJava subscription happening and you want to point it to a specific scheduler, if you inject which scheduler or thread you use into your code, then when you're actually testing, you can easily swap that out and pass in a test scheduler. Now, this is how I did it previously. But Dan, you had a suggestion on how this can be done way more easily, right?
Yeah, so RxJava plugins, again, has this way of actually overriding what the way that the default schedulers work. And so normally I wouldn't mess with it, but for testing, you can just say, hey, every time someone requests an IO scheduler, actually just give them immediate.
Oh, wow. I really have to look at this RxJava plugins thing.
So that's super neat. And then when I first discovered that, I learned that we don't have the equivalent in Rx Android. And Jake Wharton was nice enough to add it. So it should be in whatever the next Rx Android release is. So that'll be great. It'll make testing way easier.
That's cool.
Oh, so this is specifically for the Android scheduler's main thread.
Exactly, yeah.
Okay. Yeah, okay. That makes sense.
Because there's a lot of code inside the Rx Android project that depends on that scheduler. So if you can't inject it actually, even if you're using dependency injection, it won't help in some cases because what other parts like view observables might be using it, so you couldn't inject that without the plugin.
Okay. Do you have any other sort of tips that you use for testing specifically with RxJava? What are some other things that you do usually?
Yeah, I mean, one of the really cool things about RxJava is that you can so often just insert an observable in the chain wherever you want. And so a lot of the times, we might have code that represents a fragment lifecycle, and normally you'd have to test that in an actual fragment itself or fragment activity. You don't actually have to in testing because you can just create a fake observable that simulates the lifecycle. So that's pretty cool.
Oh, nice. Okay. So basically what you're saying is you would have one sort of branch of your observable sort of chaining do stuff on say the main fragment or any UI sort of UI related activity. You would just swap that out with some dummy operator when you're testing and then continue with the rest of the chain.
Yeah, because I mean, anytime you're testing just how some code reacts to a particular observable, you can mock that observable extremely easily. It's not even really mocking at that point; it's just returning a known series of events.
Yep.
Very cool.
And then another thing I use all the time is Observable.to blocking. Now, this isn't really a great thing to use so often in actual production code because it basically says take all this wonderful asynchronous stuff that we've been talking about and make it synchronous. But it's great. It's great in testing because then you can essentially say, okay, actually at this moment, I want this observable chain to just execute everything. And then you can say, all right, now I want to examine what the first, second, third, and fourth item that came out of it are and make sure that they're actually the correct ones.
Okay, so let's talk about some of the other gotchas with RxJava that you otherwise would encounter. One big problem with using... So Android uses like predominantly Java 6, and unfortunately you don't have things like lambdas, right? So what lands up happening is it looks really sort of ugly. Dan, do you have any suggestions on how people can deal with this sort of ugliness that happens? Because typically you would have to emulate lambdas using inner static classes, which has a whole set of other problems.
Yeah, it's all sorts of anonymous inner classes that you're generating otherwise. Android Studio and IntelliJ kind of help alleviate this a little bit because they have code folding. Mm-hmm. So even if you are using it, you can use code folding in order to view the code a little easier. But actually within Trello and some other apps we're working on, we use Retro Lambda, which is a library that some people wrote in order to backport lambdas in particular to versions of Java previous to Java 8. And
interesting. So you use Retro Lambda in actual production code without any issues?
Yes, not without any issues. There was one... There was one minor, they don't call it bleeding edge for a reason. There was one minor issue that we've run into that, man, I don't really want to get into the details here. But it's a known issue, and I think they're working on it at the moment. But besides that, it works just fine. Okay. And we've been using Retro Lambda now for 8 months or something. So clearly we haven't fallen apart.
I guess the important thing is people want to get a level of confidence, and if you're using it in production apps, specifically an app like Trello, then obviously it makes sense. Then you should, if you have doubts about using Retro Lambda, well then, hopefully that helps in making that decision.
Sure, I don't want to freak people out. I just don't want to be technically inaccurate and say we've never had any problems.
Exactly. One of the issues that I've found when I was learning RxJava is about unsubscribing from observables. I wasn't sure when I should do it, if I should do it, what the importance was, what the ramifications were if I didn't. Dan, could you provide any insight onto unsubscribing and when and why you might want to do it?
Yeah, so this is a really big topic that I agreed was not really covered well at all. Because, there's all this wonderful code of, you create your observable, you do all these operations to it, and then you subscribe to it, and you're done. But what happens... This is a really easy recipe for memory leaks. So, for example, there's this concept of hot and cold observables. And so a cold observable is one that just emits data when you subscribe to it, and then it's done. A hot observable is something that could happen at any time. So, a hot observable could be clicking on a view, for example. If you have a button, whenever you click on that button, it emits this item. So if you subscribe to a hot observable, it actually, may never end. It may keep going on forever. And so if you subscribe to this button click and then you leave the activity and you don't clean up afterwards, that subscription will leak, and then by extension your whole activity will leak. And that's real bad news.
Ooh, yeah.
So you really want to take care to, when you create these subscriptions, if you know that the subscription is going to end before the context ends, then fine. You don't have to worry so much about unsubscribing because it'll finish and it'll clear out all its references just fine. But if that subscription has a possibility of not ending before the activity or fragment ends, then you want to make sure to clear it somehow. So there's kind of two different ways that I handle unsubscribing, and one of them is using something called Composite Subscription. So every time you call subscribe, it returns a subscription, and that subscription allows you to call unsubscribe. So that's fine, but what if you have 20 subscriptions in a class? That would be a real pain in the have 20 different variables tracking those 20 different subscriptions. Instead, you can have composite subscription, which you can add all of your subscriptions to, and then at the key moment, call unsubscribe, and it unsubscribes from all of them. Now, one key thing to know about composite subscription is that once you call unsubscribe on it, it's unusable. So if you want to, you cannot reuse a composite subscription. So if you have a pattern where you unsubscribe and then you later want to use it again, you have to create a new instance. The other method that we use for unsubscribing automatically is to use the lifecycle observables, the thing I mentioned earlier in Rx Android. And we set it up such that you basically give it a stream of lifecycle events. So, for example, on create, on start, on resume. And then it automatically figures out, like, okay, if you subscribe to this and on start, you probably want to unsubscribe from it and on stop. And it uses that secondary thing in order to basically, it keeps the subscription running until you get to that particular lifecycle event, and then it unsubscribes.
So the composite subscription that you mentioned, like that's one problem I always faced previously. I would use fragments, and I would typically do all my cleanup between the on resume and on pause sort of lifecycle methods. And typically always that'll happen. Like on pause, you would unsubscribe the composite subscription. And then later on, you would realize that, hey, I mean, when the fragment resumes again, like nothing seems to work. So that's a good catch. You got to make sure either you do it on destroy or you be careful about not unsubscribing when you don't. Or otherwise, on resume, you can just create a new composite subscription. Okay, here's a question that I had. If I had an observable that I knew would complete, but it would typically complete after the activity or the fragment has gone out of its life cycle. Is that still a problem?
I would say so, yes. Just because you never know, like if someone starts jamming on the back button, like you might go through 10 different activities and suddenly you're leaking all of them and you could crash.
Okay. So the problem is essentially that these would accumulate. It would typically in the end be garbage collected, but it's still a problem because it's going to that activity, which is a huge object is going to be held in memory for quite some time. Is that basically like what you're saying?
Yeah, and also, I mean, I just like being correct and knowing that when it's gone, it's actually gone. So actually, I could talk about bind fragment and bind activity. People get really confused about the difference between that and lifecycle observables. What bind fragment and bind activity do is they prevent items from being emitted after the activity or fragment goes away. And at the same time, it also unsubscribes to them. The key problem here is that it does so based on the emissions of the observable. So if you have an observable that takes like 10 minutes to emit anything and they leave the activity, bind activity is not going to save you then, because it's gonna be in the background that whole time because it doesn't know to unsubscribe yet. So those are really just for making sure that an item doesn't get emitted, and then you try to handle that when the fragment is already gone, for example. Because you might try to manipulate some view, and then you'll get a crash because the view couldn't be manipulated at that stage in the life cycle.
So this is a very Android-specific problem.
Yes, it has to do with how the main thread scheduler works.
Exactly.
And this is real inside baseball sort of thing, so I don't want to get too into detail, but there's a lot of writing online if you want to look into it as to why this is happening.
Right. So do you have any other suggestions or tips specifically towards memory leaking and what you should or shouldn't be doing, or do you think we've covered most of it?
I think we've covered it.
Okay, that makes sense. So one problem with using RxJava is that, at least like I found this, like as you start using it more and you start to understand it better, you start to think of it as a hammer and everything looks like a nail to you, right? Like you want to start using RxJava for everything.
Yeah, you see those for each iterators and you think, oh, that should be Observable.from, right?
Exactly, yeah. I mean, I seriously have thought about that because I get so conversant with RxJava that I'm like, that could just easily be done with RxJava. Well, why not use that? What are some of the problems with that? I mean, is that a problem, first of all?
I think a little bit. I mean, RxJava, like we mentioned from the first half, it's complicated. It takes a lot of time to understand. And so I think I would prefer, maybe this is just my Java background, but I prefer the imperative code if I can get it, if it makes sense. I think RxJava should only be used when it actually can add something based on its operators or its threading, concurrency, or its error handling.
I remember seeing a Reddit thread where someone was using this library by Path. It's called Priority Job Queue. I'm not sure if you guys have heard about it.
Yep.
So he asked a question. Basically, he was using retrofit, and a retrofit was returning an observable, and he was using that within the priority job queue, which was anyway in the background thread. So he was having like confusion, is it going to spawn another thread? Like, should I be using that? And really, at that point, there was no need for it to be asynchronous. I mean, you could just make the retrofit call synchronous, but because it's in a background thread, it isn't necessarily going to affect it. In fact, it makes it easier because then you can be assured that the call is over and then proceed with the next sequence of operations that you had to deal with. I had a very similar situation. Basically, in our app, we do like a bunch of bulk uploads for the photos that you take on wedding party. And we use, again, a sort of queued operation to make sure that your photos go up. And there, it just made sense to use like a sort of synchronous operation, just because there are like certain, like I said, like you either process pictures or you do things in the background. You don't always have to use RxJava. So it's important to understand that there are times when really RxJava doesn't need to be used.
People take photos at weddings?
Yeah, who would have thought, right?
I had no idea. Huh. I should look for some of those.
For that. We covered a little bit about hot and cold observables kind of in the section before, but it was kind of really in-depth to the particular topic we were talking about. Dan, do you have a good, simple example of a hot and cold observables and when we may want to know about them and why we should care about them?
I mean, the main difference to know about the difference between the two of them is just to know when their items are being emitted. So the hot observable example, like I gave from earlier, is clicking on a button. A cold example might be a network request. So you create an observable that represents a network request that you're going to get a response from, but that request doesn't actually execute until someone subscribes. And so there's, like, for example, you might have a hot observable. If no one subscribed to it, it's like a tree falling in a forest. No one's actually listening to it. But it's still, those items are still being emitted, regardless of whatever you're doing subscription-wise. Whereas with a cold observable, nothing happens with it until you actually subscribe. And another interesting thing is that with cold observables, every single subscription that you do to it is going to actually start off a new chain of events. So if you had one network request and you have 5 different people subscribing to it, you'll actually end up creating 5 different network requests. So you have to be really cognizant there that with cold observables, when you subscribe, if you're actually going to share that observable stream with multiple subscribers, that you need to do something, you need to make it multicast in some way or another.
And how do I know that I'm creating a hot or a cold observable?
Oh, man, that just takes time.
So, Dan, did you want to talk about some points of confusion? You know that I was talking just recently bringing that up. Do you want to talk about some of the points of confusion you've noticed with RxJava in general?
Yeah, one of the things I've noticed a lot is people getting confused about what on error really means. A lot of people seem to think on error means something went wrong, and now I'm going to try to recover from it. No, on error means something horribly, horribly disastrous went wrong with the observable chain. Like, it's supposed to represent the idea that your observable chain no longer can function.
It's like a try-catch almost, right?
It's an exception, yeah. It's like almost like a runtime exception. No, I mean, not specifically
But the problem was that Java programmers are so used to using try-catch just for flow.
True, yeah.
This isn't like try-catch for flow. This is like something so bad happened that we can't keep this going. So if you've got a stream, so for example, validation, like you wouldn't want to call on error when something's invalid. What you want to do is emit variables that either indicate that it is valid or it isn't valid. Because then that that stream remains constant. You don't have to like keep resubscribing to it, and you can compose the data still. Because one of the things about on error is it just jumps straight to the end wherever the error handler is. So it's just on error is supposed to be unrecoverable exceptions, and I think the reason a lot of people get confused is because retrofit and its initial implementation of how it does integration with RxJava caused all like non-success error states to be on error. And really, that probably shouldn't be the case. It should be the case that it should be wrapped, and then you can handle this HTTP status code yourself somewhere later in the chain. And my understanding is that they're probably going to switch to that in a later version of retrofit.
That'd be cool.
Right, that makes sense.
Another issue that can creep up on you that people don't know is going to creep up on them is something called back pressure. And this was something that was handled pretty late in the game for RxJava. And the idea behind back pressure is pretty simple. If you have an observable emitting a bunch of data, it obviously takes some amount of time for your code to process each of those emitted items. Mm-hmm. And suppose that the time it takes to process those emitted items is longer than the time it takes between each emitted item. And so if my observable is going to emit 1,000 items and it takes me 10 seconds, in a second, it takes me 10 seconds to process each one of those items, like I'm going to end up with just a huge amount of back pressure. And that's basically, I can't process the data as quickly as the observable is delivering it to me.
Gotcha.
So this is an interesting problem to try to handle, because like it's basically like you're running a little mini server in your code, because servers have to deal with this problem all the time. You suddenly get on the top of Hacker News, and now you have to deal with 50,000 extra requests coming to your web server that you can't deliver that quickly. So back pressure is something that creeps up on you because it's not a problem until it suddenly is, and then your code crashes all over the place. Because there's a buffer that exists that allows for some amount of buildup. But once you get too much past that buffer, your app just blows up. And so the usual way to handle that is you need to make one of two choices. Either, through one of three choices. You can either make the buffer a little bigger if that's all you really need is just a slightly larger buffer. You can slow down the rate at which items are emitted somehow, or you can choose to drop some emitted items. Like there's no one excellent solution to it. You just have to figure out some way to make the stream as fast as the way you're processing it.
Do you typically find that issues with specific operators, other specific operators that sort of tend to like run into this problem more often, or is it just like a generic thing? For example, I know like the zip operator, like you are prone to run into back pressure sort of like issues with zip. If you have two observables where one is like emitting it at a huge rate, and there's one that's maybe like a network call that comes like once in every 10 seconds or something, is that sort of like a situation that you would run into back pressure?
It's typically not, for me, not the particular operators, but just what the source is. Mm-hmm. So if the source is something that emits a whole bunch of items, that's when it becomes really useful to use something like DistinctUntilChanged or Filter, just so you can have fewer items. You only need to pay attention to the ones that really matter.
Mm-hmm. Yep.
And how do you typically catch these back pressure risks? How would these like sort of like materialize in your app?
How do you know you have a back pressure problem? Yeah.
Exactly.
Usually the app crashes with a stack trace saying that the ring buffer is full.
That's pretty simple.
Yeah, it's easy to tell when you've got the problem. In particular, we ran into this a couple months ago because they decided to change the size of the buffer. So the buffer, I think, used to be like, 20 times larger than it is now. Because obviously, having that buffer takes up space. And so you want to have a buffer that's just the right size to handle all of your code. And they dramatically lowered it based on just some usage case. So our answer was to raise it up, because I think it was reduced by 20 times, and so we just like doubled what the default was, because that was pretty much enough for us.
And how would you do this? Typically, how would you like increase the buffer? Is like their standard way of doing this?
Yeah, I don't remember exactly what the method call is.
Okay, but we can add a link to the show notes for that, I guess.
But I would not go to that as your first solution necessarily. I'm not very proud of that being our solution. The better solution is to slow things down or to drop items as necessary, because that's more sustainable than just your solution shouldn't be every single time you run out of space to add more space, because that is
more memory.
Yeah.
And this is where some of those other operators like debounce and buffer and those also come into, they come in handy, where you can sort of like ignore a bunch of them.
Mm-hmm.
All right.
Yeah, and I had one last thing that really I only just recently realized, and I just wanted to share, which is that there's this, when you call FlatMap, you're creating a new observable essentially. So that new observable, then you can apply your own operators on that. And then you can take those operators, maybe one of those is a flat map, and you can create the observable you create in there and add some operators to that. And if you do code like that, yes, it's literally correct, but reading it is really difficult, because your code is kind of has this tree hierarchy now. One of the cool things I like about RxJava is just this chain of line after line after line of what's going to happen to each data emitted. When you have these nested flat map operators, it gets really confusing very quickly. And so my advice is, if you're writing FlatMap and you're going to have the data inside of it need some operators called, to split that out into some separate method or action somewhere, because then it makes the code just so much easier to read. It does the exact same thing, but just a lot easier comprehensively to comprehend.
Do one operation. Exactly.
Don't break the chain or Dan will get angry.
Cool. I think that wraps it up for the RxJava topic. As Kaushik said before, we could probably go on this for another 2 days, and it would be fun too, because I myself have learned a whole bunch. I don't know about you, Kaushik, but I know I've learned a ton.
Oh, absolutely.
So that said, I think we're going to wrap up the show. And we, as usual, we wrap up the show with a couple of awesome picks of the week. Dan, would you mind sharing some of the things that you found on the web?
Yeah, well, this isn't a recent find necessarily. It's a talk from a few years ago, but I figured while I'm on this podcast, I wanted to share it because I really love it. It's this talk by Rich Hickey, the creator of Clojure, called Simple Made Easy. And it's really about this fundamental concept of what is the difference between a simple solution to a problem and an easy solution to a problem. And these are two different things, and he goes over it really well, and it's kind of formed a basis now for how I evaluate how good a solution is, because a solution is better if it's simple than rather than if it's complex. Mm-hmm. So
when I saw Dan add this into the notes, I was like, that looks interesting. I clicked it, and then I landed up watching the whole thing. So
yeah, it's super great. Yeah. I love it. And then the other one, we mentioned it earlier, but Victor, the library that we just released, this is total blatant self-promotion, but it's free, so whatever. I think it's really awesome, and I'm super excited about releasing it. So that's my other pick.
This week for my picks, I just have one. It's Realm.io, and Realm is a mobile database. It's basically a replacement for SQLite and core data, so for Android or iPhone or iOS projects. And it's basically an object database. So if you're interested in a different type of data persistence mechanism, you might want to check out Realm. It has it's been out for a little bit now, but if you're interested in maybe you're getting tired of SQLite, which I know a lot of people are, definitely go take a look at Realm.io. I found it pretty interesting.
Nice. So my pick for this week is another talk. It's called Therapeutic Refactoring, and it doesn't actually deal with Android or Java, but the code is actually in Ruby. But this is possibly one of the best talks on refactoring that I've seen in some time. I go back and watch this again and again just because it's done really well. We'll add a link to this. It's on YouTube. It's basically a talk where Katrina Owen talks about how she approaches refactoring, and she actually does almost like a sort of live demonstration of one really nasty chunk of code that was there in her production application, and she basically takes it apart. She adds tests as a sort of safety harness, and then goes back and demonstrates how you should be approaching refactoring. It's an amazing talk, so I definitely very, very highly recommend people watch that. It's an amazing talk. All right, so I guess it's time to wind this episode down. So if people want to reach you, Dan, what's the best way they should?
Probably the easiest way is to get me on Twitter. My Twitter handle is danlew42. My last name is spelled Lew, not one of those LIU people. So that's. And then if you also want to check out my blog, you can get to it pretty easily. It's just at danlew.net.
You had a previous blog as well, danielcodes.blogspot.com. You said that was basically a mirror.
It's basically a mirrored on the new blog now, anyways. So if you happen to come across that, I'm the same person.
Okay.
Yeah, also, if you're interested, Trello is hiring right now. We're not actively hiring any Android developers, but I know that we just put up a listing for Windows Phone. Maybe you like that too. But that's at Trello.com/jobs if you're interested.
Okay, cool. So you can find all the show notes for this episode at fragmentedpodcast.com/episodes/4. Everything that we have talked so far in this episode, we'll add links to that, so you'll find that pretty useful. Now and then we also add things that we don't necessarily discuss in the episode, so they're nice Easter eggs. So you should definitely look at all our episodes and read the show notes. There's a lot of gold in there. If you have feedback or suggestions for us, please feel free to comment right at the show notes, or you can send a tweet directly to both Donn or me. Send it with the hashtag Fragmented Podcast, and that makes it just easier for us to filter it out. But if you tweet at us anyway, then that should work too. If people want to tweet at you, Donn, where do they do that?
You guys can reach me at Twitter handle at Donn Felker. That's DONNFELKER. That's with 2 N's. You can also hit me up on my blog at DonnFelker.com.
Nice. And if people want to reach me, I'm Kaushik Gopal. That's KAUSHIKGOPAL. That's my full name on Twitter. Or you can go to my site. That's KAUSH.co. So you can basically find most of the stuff that I do online there. Thank you so much for listening, and we will catch you in the next episode.